crack defense. So let's quickly get started. So first we have is the phenomenon of refraction. So what is refraction? When a ray of light is traveling from one medium to another, it just changes its direction. So for example, if the ray of light is starting from water medium and then just goes towards air medium, which is lighter in density. So the refracted ray would be moving away from the normal. Similarly, if it's opposite, we have a lighter medium at the top from where the incident ray is coming and a denser medium at the bottom where the refracted ray is going. So it just will move towards the normal, that is this one. Now there are two laws while following this refracted ray. So we have law 1 which says incident ray, refracted ray and normal lie in the same plane at the point of incidence, that is this point. And law 2, or we commonly know it as Snell's law, it is n1 sine angle of incident equal to n2 sine angle of refraction, or either we can write it as n1 sine theta 1 n2 sine theta 2. So here n1 is incident index and n2 is refractive index. So now we have lateral displacement, the perpendicular shift of the incident ray from the emergent ray. It increases with increase in thickness of glass and, or we can say, in the angle of incidence. Coming to the next point, we have reflection. Now what is reflection? It's just the incident ray pointing on the surface and reflecting back in a particular direction. So there are two laws needs to be followed here. Law 1, where incident ray, reflected ray and normal all lies in the same plane. Law 2 says the angle of incidence and the angle of reflection would always be equal. So this angle here, theta 1, and this angle here are going to be equal when the reflection happens. Now coming to the lateral inversion, the change of the sides of an object and its mirror image is what lateral inversion is. Now coming to the concave mirrors that we usually see in many of the places, like it is used in torches, it's used in searchlights, vehicles and even shaving mirrors. There are plenty of examples around us. So we have some 6 conditions there, how we place the object and how we get images. Let's discuss one by one. So first we have an object which is placed at infinity and in front of it we have a concave mirror. So its image would be formed at focal point F and would be highly diminished and real and inverted. Coming to the second position, we have an object placed somewhere between infinity and pole. So where the image formed will be between C and F, that is curvature of the mirror and focal point, would be inverted and real. Third case we have where object is placed on curvature of mirror and the image formed will be again at the same point C but would be real and inverted. Fourth case we have where we have image somewhere between C and F but the image formed would be beyond C, which will be and real and inverted. Fifth case we have where the image is placed exactly at the focal point and image will be formed at infinity, which will be very highly enlarged and inverted and real. Now the last case here would be the object placed between somewhere F and P, pole of the mirror, where the image formed would be beyond the mirror and would be highly enlarged but virtual and erect. Let's go for such cases for convex mirror. So these mirrors are usually used for rear view mirrors in automobiles. Now two cases here. First we have where image is placed at infinity, object is placed at infinity and we have image obtained at other side of the mirror at focal point F, which is again erect and virtual. Now here second case is where object is placed somewhere between infinity and pole, but the image we get would be highly diminished, erect and virtual. Now we have a concept as prism. What happens there? The phenomenon used is dispersion, by which light splits into 7 colors when passed through an equilateral prism. Here, angle of incidence plus emergence angle is equal to angle of prism plus deviation. Now, how does this compound microscope works? Requires two convex lenses with varying focal length for an enlarged view of object nearby. So the objective lenses is one with lesser focal length and the other side would have higher focal length. Now let's discuss about telescope a little bit. So telescope requires two convex lenses. Objective is of larger focal length here in order to obtain image of an object far away. The power of lens in diopter equal to 1 upon focal length in meter. Okay, now we get the lens formula, which is 1 by f equal to 1 by v minus 1 by u. The photographic camera is based on the principle that if an object is placed beyond 2f of a convex lens, it always forms a real diminished and inverted image between f and 2f of the other side of the lens. So the eye usually functions on the same phenomenon. Thank you.